Hello friends, in this video I am going to explain the part modeling and assembly of a knuckle joint using Creo 7.0. Now let's see the construction of a knuckle joint. In a knuckle joint, one end of the rods is converted into a fork end with double eyes and the other end is converted into an eye end with single eye. The eye end of the rod is inserted into the fork end and a cylindrical pin will be introduced through the aligned holes. The cylindrical pin is held in its position with the help of a collar and a taper pin. Here we can see the exploded view of a knuckle joint. We need to assemble all the 5 parts together to get the assembly of a knuckle joint. We all know that quarter joints are used for connecting two rods with perfect axial alignment, and quarter joint does not permit any relative angular play between the two rods. But knuckle joint can be used for connecting two rods having intersecting axes, and we can use knuckle joint while converting a reciprocating motion into rotary motion and vice versa. Now let's move on to the modeling of a knuckle joint. Here we can see the details and the dimensions of different parts of a knuckle joint. Let's start with the modeling of the fork end. We shall start with the arc of radius 18. Open a new file, part. We shall rename it as fork. Remove the tick mark on use default template. Give OK. Select millimeter Newton second part solid absolute. Give OK. Select extrude option. Select the front plane. Select the sketch view. Now we shall draw the center lines. We shall start with the arc of radius R18. So instead of drawing the arc, let's draw a circle of radius 18. So go to circle command, select center and point, draw a circle. Next we need to draw the arc of radius 36. We shall draw that arc as a circle. Now we shall change the dimensions of the concentric circles. The inner radius is 18. First we shall change the diameter option into a radius option. It is 18 mm radius, enter. And the outer circle radius is 36. We shall change this diameter symbol into radius symbol by left clicking and selecting the radius option. Change the dimension into 36. Go to refit. Now we have completed the concentric circles with radius 18 and 36. Now we have to extend this portion as a square end with dimension 36 by 36. So go to rectangle, select corner rectangle. Okay, now we have to change the dimension. The thickness of the square end is 36. So we can change it as 36. The distance between the center of the arc and the end of the octagonal end is 109 mm. But now we need not consider the 45 mm octagonal end. Now we shall dimension the distance between the vertical center line and the starting part of the octagonal end. We all know that the distance given is 109, but now we need not consider the 45 mm. So it will be 109 minus 45. So this length will be 109 minus 45. Enter. So it is 64. Now we shall trim the unwanted portion with the help of delete segment. Let me draw a rectangle using the corner rectangle option. Select. Click. Now let's dimension this portion. That is from this left end to the starting part of the octagonal end. Since we are not considering this 45 mm portion now, we shall take this dimension as 147 minus 45. Enter. So this length is 102 mm. We shall also remove the unwanted region using delete segment option. Now let's mirror the lower part with respect to the horizontal center line. Select the lower part, go to mirror command, mirror it with respect to the horizontal center line. From this diagram we can see that the inner radius of the arc is 18 mm and the outer radius of the arc is 36, and the length between the center of the arc to the start end of the octagonal end is 64, and the distance between the end of the rectangular portion to the start end of the octagonal end is 102 mm. Give OK. Now let's slightly tilt it. The total thickness of extrusion is 36 mm. So let's change it to 36, and we need to select the extrude symmetrically on both sides. Give OK. Now we have partially completed the fork end. Select the standard orientation. Now we need to draw the double eyes. Let's go for the next extrude command. Select the top surface. Go to sketch view. Include references. Close it. Now we have to draw the two concentric circles on the lower end. The inner circle is of diameter 30 and the outer circle is of diameter 60. Go to circle command, select the center and point option, draw the inner circle and draw the outer circle concentric with the inner circle. Now let's change the dimension. We know that the inner circle diameter is 30 and the outer circle diameter is 60. So the inner circle diameter is 30 and the outer circle diameter is 60. Now we have drawn the concentric circles on the upper surface of the lower arm of the fork. Now let's give OK. We need to extrude in the downward direction. Change the direction, and the height of extrusion is 22. So change it into 22. Give OK. Now go to view option. Switch on the reference planes. Now let's select the eye end. Go to mirror. We shall mirror this eye portion with respect to the middle plane. Select the middle plane. Now we have created the eye portion on the upper arm of the fork. Give OK. Go to standard orientation. Now we have to remove the extra materials which are inside the eye portion. So select the extrude option. Select the top surface. Go to sketch view. Select the references. Give close. Now select the circle with center and point. Draw a circle with the same center. We have drawn a circle at the top end of the eye. Give OK. Change the direction. Let's select the extrude to intersect with all surfaces. Remove material. Now we have removed the extra material which was inside both the eyes. Select the standard orientation. Now we have to extend the square end as an octagonal end of length 45 mm. So select the extrude option, select the end plane, go to sketch view, insert references, give close, go to sketch, go to palette option, select the polygons, select the 8-sided octagon, click and drag it and place it somewhere like this. Close it. Now we have to place this octagon at the center of the square end. So let's constrain it. Select the coincident. Select the center point. Click on the vertical center line. Now we have aligned the center of the octagon on the vertical center line. Once again select the coincident option. Select the center of the octagon. Click on the horizontal center line. Now we have relocated the center of the octagon at the center of the square. Once again select the constraint option. Select one of the horizontal edges of the octagon. Select the horizontal edge of the square. Delete. Now we have aligned one of the horizontal edges of the octagon with the horizontal edge of the square. Let's give OK. Let's slightly rotate it. We know that the length of extrusion is 45 for the octagonal end. Give OK. Now we have extended the square end as an octagonal end. Now we have to insert a fillet on this particular edge. Go to round option. Select this edge. Okay, let's randomly give a radius of 7. It is exactly matching. Give OK. In the same way, we shall insert the fillet on the other inclined edges. Select the round option. Select this particular edge. Give OK. Now rotate it. Select the edge. Give OK. Once again select the round option. Select the inclined edge. Give OK. Now we have filleted all the 4 edges. Now the octagonal end need to be extruded further as a cylindrical rod of diameter 30 mm. So go to model, select extrude, select the plane of extrusion, select the sketch view, select the references, give close, go to circle, select the center and point option, select the center of the octagon, draw a circle. The diameter of the circle is given as 30 mm. Change the diameter of the circle as 30. Enter. We have to extend the circle as a cylinder. Give OK. And let's assume the length of the cylinder as 25 mm. The value is not given. Give OK. Select the standard orientation. Now let's change the color of the fork end. Go to view option. Select appearance. Select the red color. Select the part option. Click on the part. Now we have changed the color of the part into red. Save this file as fork. Give OK. Now we have completed the modeling of the fork end. Close this model. Now we have to model the second part, that is the eye end. In this diagram, the distance between the center of the eye to the end of the octagonal end is given as 120 mm. First, let's exclude the cylindrical and the octagonal end. So, excluding that part, the length will be 120 minus 45, which is equal to 75 mm. Let's model the eye end now. Go to a new file, part, change the part name as eye. Remove the tick mark on use default template. Give OK. Select millimeter Newton second part solid absolute. Give OK. Now we shall draw the part. Go to the extrude option. Select the front plane. Go to sketch view. Draw the center lines. We shall draw the eye end from the center of the eye. Go to rectangle. We know that the length of the rectangle is 75. That is 120 minus 45. Enter, which is 75. And the thickness of the square end is 33. 33. Let's switch off the reference planes. Give OK. Select the extrude symmetrical option and the thickness of the extrusion is 33. Give OK. Select the standard orientation. Let's go to view option. Switch on the reference planes. Now we have to model the eye portion of the eye end. So go to model, extrude, select the middle plane as the reference plane. Go to sketch view, include the reference lines, close it. Now we need to draw the eye with inner diameter of 30 and outer diameter of 60. So go to circle, select center and point, select the center of the first circle, then draw the second circle, which is a concentric circle. Now we need to change the diameter. The diameter of the inner circle is 30. The diameter of the outer circle is 60. Now we need to extrude this eye portion for a thickness of 36. So give OK. Select symmetrical about center axis. The depth of extrusion is 36. Give OK. Now we need to remove the extra material which is inside the eye. Once again go to extrude option. Select the plane of extrusion. Go to sketch view. Select the references. Select the inner circle. Give close. Now go to circle command. Select center and point. Draw a circle of diameter 30. Give OK. We need to change the direction of extrusion. Select the option extrude to intersect with all surfaces. Remove material. Give OK. Now we have to include the octagonal part of the eye end. So go to extrude once again. Select the surface. Go to sketch view. Select the edges of the square as references. Close it. Now go to palette option. Select the polygons. Select the 8-sided octagon. Click and drag it. Close this window. Now we have to move the center of the octagon to the center of the square. So we need to apply the constraint. Select the coincident constraint. Select the center of the octagon. Select the vertical reference line. Now we have aligned the center of the octagon on the vertical axis. Once again select the coincident option. Click on the center. Click on the horizontal reference. Now the center of the octagon is aligned with the center of the square rod. Now we have to change the dimension of the octagonal end. Once again apply the coincident constraint. Select the horizontal edge of the octagon. Select the lower end of the square. Click delete. Now both the edges are made coincident to each other. Give OK. Tilt it. We need to extrude the octagonal end for a depth of 45. Give 45. Click OK. Now we need to include the circular end of diameter 30 mm on the octagonal end. Once again select the extrude option. Select the plane of extrusion. Go to sketch view. Select references. Draw the reference lines. Close it. Go to circle command. Select center and point. Go to the center of the octagon. Change the diameter of the circle as 30. Enter. Now we can extrude it. The length of extrusion is not given. Let's assume the length of extrusion as 25 mm. Give OK. Select the standard orientation. Now we have to include the fillet on this particular edge. So go to round option. Select the fillet. Okay, we can change the fillet radius as 6 mm approximately. Give OK. In the same way, we shall include the fillet on the other inclined edges. Go to round, select the edge, give OK. Go to the third inclined edge, select the round option, select the edge, give OK. Go to the fourth inclined edge, select the round option, select the edge, give OK. Go to standard orientation. Now we shall change the color of this eye end. Go to view, select appearances. We shall select a light color. Select the part, then click on the part. Now we have changed the color of the eye end. Now let's save the file. Let's give a new file name, EOE. OK. Now let's close this model. Now let's model the third component in this knuckle joint assembly. So we need to draw the head portion of diameter 45 with a thickness of 15 mm. Then we need to further extend it 102 mm with a diameter of 30. Let's start a new file. Change the file name as pin. Remove tick mark on use default template. Give OK. Select millimeter Newton second part solid absolute. Give OK. Select the top plane as the reference plane. Select the extrude option. Select the sketch view. Draw the center lines. Now let's start from the head portion of the pin. Go to circle. Select center and point. Draw the circle. Change the diameter to 45. Refit. We need to extrude the circle for a depth of 15. Give OK. Let's change the direction of extrusion. Change the depth of extrusion as 15. Give OK. Once again go to view option. Switch on the reference planes. Go to standard orientation. Now let's extend this head portion as a cylindrical part of diameter 30 mm and a length of 102. So go to the bottom surface. Go to model. Select extrude. Select the bottom plane. Select the sketch view. Go to circle. Select the center and point. Draw the circle. Change the diameter of the circle as 30 mm. 30 mm. Let me tilt it slightly. Give OK. We know the length of extrusion is 102. Give OK. Go to standard orientation. Now we have to make a taper hole. Instead of making a taper hole, we can draw the taper pin and remove the material inside. Now let's select the revolve option. Select the front plane as the reference plane. Click on the sketch view. Include the reference. Close. Draw a center line. The distance between the center of the taper hole to the bottom end is 15 mm. Change this distance as 15. Now we have to draw the taper pin instead of making a taper hole. Go to line command, select line chain. We know the total length of the taper pin. Go to dimension. Click on the two boundaries of the taper pin. It is given that taper 1 in 30. The diameter of the larger end is 6. Automatically the diameter of the smaller end will be 4 mm. Now we need to change the dimensions. Select all the dimensions. Go to modify. Remove the tick mark on regenerate. The diameter of the smaller end is 4 mm. So this value will become 2 mm. And the diameter of the larger end is 6 mm. So this value will become 3 mm. We know the total length of the taper pin is 60. Half the value of this taper pin is 30 mm. Give OK. From this diagram we can understand the radius of the larger end is 3 mm and the radius of the smaller end is 2 mm. Total length of the taper pin is 60 mm and half the length of the taper pin is 30 mm. So let's give OK. Now we have created the taper pin. So remove material, give OK. So now we have created the taper hole with taper 1 in 30. Go to standard orientation. We shall also change the color of the pin. Go to view, change the color as yellow. Select the part option and click on the part. Now we shall save the model. Give OK. Let's close this model. Now we need to model the fourth part in this assembly, which is a collar. Open a new file, part, change the file name as collar, remove the tick mark, give OK. Select millimeter Newton second part solid absolute, give OK. Select the extrude option, select the top plane, go to sketch view, go to view option, switch off the reference planes, go to sketch. Let's draw the center lines. Go to circle, select the center and point, draw the first circle and draw the second circle. The diameter of the smaller circle is 30 and the diameter of the larger circle is 45. Refit. Give OK. We shall extrude the component symmetrical about the center plane. And the total depth of extrusion is 15 mm. Give OK. Go to view option, switch on the reference planes. Now go to standard orientation. We have to incorporate the taper hole on the collar also. So go to model, select the sketch option, select the front plane as the reference plane, select sketch, Select the sketch view, include the references, we close. Now we need to draw the taper pin of taper 1 in 30. Go to line, select line chain. We know the total length of this taper pin. Go to dimension, dimension the total length. We know the diameter of the larger end, the diameter of the smaller end. We know half the length of the taper pin also. Now let's change the values as per the given dimension. Total length of the pin is 60 mm. Half the length of the pin is 30 mm. Radius of the larger end is 3 mm. And the radius of the smaller end is 2 mm. Now let's check the dimensions. Total length of the taper pin is 60. Half the length of the taper pin is 30. Larger diameter of the pin is 6. And smaller diameter of the pin is 4. Insert the center line. Give OK. Select the revolve option. Now the pin has been created. We have to remove the material. Give OK. Now the taper hole is being created. Now let's change the color of this collar. Go to view, select appearances. Let me select the blue color. Select the part. Click on the part. Save a copy of this file. Give OK. Now let's close this file. The last and the final part is modeling of the taper pin. Let's open a new file. Part. It's a taper pin. Remove the tick mark on use default template. Give OK. Select millimeter Newton second part solid absolute. Give OK. Now let's select the front plane. Select revolve. Select sketch view. Select view tab. Switch off the reference planes. Go to sketch option. Draw the center line. Now let's draw the taper pin. Go to line. Select the line chain. Draw the taper pin. We know the total length of the taper pin. Now let's change the dimension using modify dimensions. Select the sketch. Go to modify. Remove the tick mark on regenerate. We know the total length of the taper pin is 60. Radius of the larger end is 3 mm. Radius of the smaller end is 2 mm. Half the length of the taper pin is 30 mm. Give OK. Go to refit. Give OK. Now we have created the taper pin. Give OK. Go to view option. We can change the color of the pin. Let me select a brown color. Go to part. Click on the part. Go to file. Save a copy of this file. Give OK. Now we have completed the modeling of all the 5 parts. We need to assemble all the 5 parts together to get the assembly of a knuckle joint. Let's close this file. Now let's open a new file. Select assembly. We can give the name as knuckle. Remove the tick mark. Give OK. Select millimeter Newton second assembly design absolute. Give OK. Now let's go to assemble. Select assemble. Select the first part of the assembly, that is fork. Give open. Change this part as a default part. Give OK. Go to view. Switch on the reference planes and reference axis. Go to assemble once again. Click on assemble. Select the eye end. Open it. Now let's move it. Select the vertical axis of the fork and the vertical axis of the eye. Make it at a distance of 0. Now slightly rotate it. Now select the top surface of the eye end and the bottom surface of the fork end to get coincident. Now we have to arrest the rotational movement. Select the front plane of the eye end to get coincided with the front plane of the assembly. Now it is fully constrained. Give OK. Now let's assemble the third part of the assembly, that is the cylindrical pin. Go to assemble, select assemble, select the pin, open. Now let's coincide the central axis of the pin to get coincide with the central axis of the eye. We will make it coincident. Now we have to make the top end of the fork to get coincided with the bottom end of the head. Okay, now it is fully constrained. Give OK. Now let's assemble the fourth part of the assembly. Go to assemble, select the collar, give open, move it closer, slightly tilt it, make the inner surface of the collar and the outer surface of the pin to coincide, and the axis of the hole in the pin and the axis of the hole in the collar should be oriented. Now both are aligned and assembled. Now we need to assemble the last part. Give OK. Go to assemble, select taper pin, give open, standard orientation, make it closer, make the axis of the hole and the axis of the taper pin coincident. Now we have to make the datum plane of the taper pin coincident with the right plane of the eye end. Make the distance 0. Now we have assembled all the parts together and it is fully constrained. Give OK. Go to view, switch off the reference planes. Thanks for watching this video. Hope you have enjoyed. Don't forget to like this video, give your comments, share it with your friends, and don't forget to subscribe this channel.